Hey everyone, thank you very much for joining me again. This is the second episode of the JPA Fundamentals series. Thank you very much for being here, and we will continue our discussion on entities and the context with JPA and Hibernate. If you're watching the event live, don't forget that we have a live chat there as usual. If you're watching the event recorded, you can ask me the questions in the comment section. And of course, you can follow me as well on Twitter and LinkedIn as usual. With that being said, I would like to continue our discussion since last time, and I'm gonna step directly in the subject today, and I wanna first of all remind you what we've been doing. So in the previous lesson, which was the first one, we discussed ways in which you connect to a database using Hibernate as a JPA implementation. We discussed that JPA is a specification. Hibernate is one of the frameworks implementing this specification. And we created a couple of examples in a project where you learn to connect using a persistence XML file, but also using directly Java code. I know there was some misunderstanding here, which I want to clarify first, and then we will step into the continuation. We will actually discuss on the entities and the first basic annotation that you need to know, and of course demonstrate the way they work. I'm waiting for your questions and comments in the live chat, so I always keep an eye on the live chat, which is here on my left side. And with that being said, let's begin. Or let's continue. So I have already prepared the project, so we don't have to like code this foundation from zero every time, because we will save time this way. But I remind you that we use 3 dependencies in our POM XML file, and those are the Hibernate core dependency, because of course we are using Hibernate, as I said, as the JPA implementation. We are using the MySQL driver because I use MySQL here as my database management system. You don't necessarily have to do that, but depending on the database you use, you have to use the appropriate driver. Remember that an object relational mapping framework, an ORM framework such as Hibernate, it doesn't connect directly through the database. It still uses JDBC behind the scenes. So any Java application has this philosophy where the interfaces in the JDK are separated from the implementation, which is vendor provided. That's why regardless of the way you will connect to your relational database, remember you always need to add the appropriate driver. So you use MySQL, you use the vendor provided driver for MySQL, you use Postgres, you need to add the driver for Postgres, you use Oracle, you have to add the driver for Oracle, and so on and so forth. And because creating the connection to the database, it requires also an object to manage the connections. We will use what we consider to be today probably the best connection pool data source, which is Hikari. So that's why I also added Hikari, that I have used here in the custom persistent unit info, which is the object providing the details for connection to the database. Now, the thing I would like to clarify first, because again, so from now on I will not use the persistence XML file in all my examples. That's just because I wanna save myself from having XML configurations in my project. And anyway, in projects today, for example, if you create a Spring Boot project, you will not see XML configurations anymore. No, that's the point. So we will work in the say today's way, where the configuration is done through the code. But I would like to clarify the questions I got after the previous video, because you have seen me putting this in code, like, you know, to create a custom persistent unit info like we did in the previous video, we had to implement this persistent unit info interface. This is the interface the JPA implementation use this as a contract to understand the details to connect to a database, and then you have to override one or multiple methods. You have to override all of them, but you have to really implement one or multiple methods depending on what you like to do here. And the most essentials are those that we have implemented, where we have provided the unit name. You need to have a unique unit name depending on how many persistence unit you have, but usually it's only one, but it has to be a unique name. And then you have to provide the name of the, say, I called it the main class of the implementation. Remember that Jakarta Persistence API is a specification. It has multiple implementations. Hibernate is one of them, probably the most used today. But because you might have multiple implementations, the specification can't say which is the main class. The main class has to come from the implementation. So this is the reason we need to tell the name of the so-called main class of this implementation, which would be different in case you would have used a different JPA implementation, no? And then transaction type, which in case it's a standalone application, it will be resource local. If you would use a container that provides you Java Transaction API, you would have to choose JTA here. But again, in most cases, we are today in the situation where our app manages the transactions itself. And then the data source that also comes with the connection to the database itself. So the data source class manages the connections, and then the JPA implementation, Hibernate in our case, uses the data source. And the list of the entities, which I would like to put it up here just to have all the implemented methods in the same place. And that's it. I mean, not that's it, but that's the minimum you need. So there are other things down below. We might discuss them in some future lessons, but for us this is the minimum. Now the clarification is, you don't have to put this hard-coded. Normally in a real-world application, they will be read from somewhere, especially the credentials, for example, which of course you cannot put them in code. Yeah, you always have to keep them somewhere secure, like in a vault. Any kind of things that you see here, they are most likely configurable based on the environment. So it's unlikely that you will use the same database throughout the whole environments of your application. You usually have in a real world app a dev, an UAT, a production, maybe some other environments that you use to test your application in different scenarios. So everything has, or almost everything is configured and has to come from some properties. So yes, I have implemented this hard-coded here because it was just easier for me, but normally you would have to read them from somewhere, and then what you can do is declare them like private final string persistent unit name, no? And then instead of hard coding it, you just take it like this through the constructor, and the same for the rest. Okay, it's the same for the rest. And then of course my code won't compile anymore unless I give the pu name. So I can say string pu name, which is read them from somewhere. Depending on the app, you can read it from an environment variable, you can read it from a file, you can read it from an endpoint, you can read it from a database. Unlikely, but you could even that. And that, so pu name, no, and that's basically it. So, and then you give it as a parameter here, and the same. These are basically the configuration itself. So it's map. Let me see how is it declared to make sure that I'm putting it correctly. So sorry for that. Yeah, it's a map, normal map. So I can say map of normally string and string props. No, new hash map, something like that. And this you can also read from your properties, no? So I'm telling you this because I had these questions, no? So I had these questions on why did I hard code things, and is that a real world stuff? And of course it's not. So it's just for demonstration purposes. Normally you read them from somewhere and then you create this object, and then from here you create everything else. Even if you have a Spring application, remember, no, you have the properties files. In a Spring Boot project, you have the application properties files, and you have the those details there. So that's where the app reads them, behind the scenes creates the persistence unit info file, and then creates everything else. Now, in terms of the classes here, usually you don't have to provide them to enumerate them somehow. It's easier with a framework to find who they are through reflection, and that's what a framework such as Spring does, but I will get into those details later. so that's basically to answer this question, to clarify this about, I don't want you to remain with bad things like you should hard code stuff in the code, but sometimes with examples you have to do that, because otherwise I would lose a lot of time, and I only have 1 hour to put something of value here that will teach you stuff you can use in real world apps, and you can create very robust applications with that. So now let's go further. So I want to see my database. I have a table called employee, and it's a very simple table I have actually created yesterday with another video. It has an ID, a name, and an address. So you know that first thing you do when you work with an ORM framework, you have to represent all the entities from the database as classes. So that's exactly what I'm going to do. I will represent this employee, and then I'm going here and I will create a package. Let's call it entities. And in the entities package, I will create this employee class. And in this employee class, first of all, to mark it as an entity, you have to use this entity annotation. Now I see the question in the live chat is, what is the difference between using here, you have a name attribute, and the question is, what is the difference between this and another annotation that I anyway wanted to show you, which is table. So it looks similar. Now you have a name attribute for both of them, but remember that the entity annotation its only purpose is to say that the employee here is modeling an entity from the database. So an entity in the database is any kind of concept that describes something through multiple attributes, which translate in the database as a table, the attributes being the columns on the table. No, so in my case here, employee is an entity. It describes an employee having the characteristics, the attributes ID, name, and address, such that all the rows in the table will be a record representing one such employee, and each column represents one of its characteristics. And of course, in case of the application, the class describes how the table looks like, while every row will be an instance of that class. No, because the instance of the class is the record in the database. So yeah, that's basically why I have to do that. Now remember also that when you work with ORM, we discuss about working with a context. So this is one of the things that I put an accent, that I bolded last time, and I consider it very important to remember, is that you never think about operations with the database directly when you work with an ORM framework. Like in our case with Hibernate, you think in terms of working with the context. So you never work with the database, you work with the context. Okay, this is the context. the context, you can imagine it as a collection of instances of entities. So inside this context, you will add all those instances that you want Hibernate to be aware of. Hibernate, or whatever other implementation of JPA you have behind the scenes, will not be aware of anything else than what is inside this collection that we call the context. So this is why the context is very important. If you want Hibernate to understand, to see something, to see an object, it has to be here in the context. If you want Hibernate to work with that object, it needs to be here in the context. And then the database itself, you don't even have to care, that's abstracted. So when you work, you will consider that you work with the context, but you will allow the implementation to mirror the context to a database. Of course, depending on how you work with the operations and how you configure the context, the framework might mirror the context in a good or in a bad way, and that's where, and we will work on that, possible mistakes may appear, like for example n+1 queries or unnecessary updates. But again, we will discuss about that. But the idea is that you always work with the context. So regarding your question, when you give a name here, you give a name to the instance in the context, but it's not the name of the table. It's not necessarily the name of the table that it will be used. It's just giving it a name of the entity. So giving it a name of how the entity is represented in the context. While the table annotation, which we most usually use, is to make sure that the implementation knows how the table is named in the database. So in my case, I can use here, and I must use here employee. Okay, because employee is exactly the name of the table in the database. Now, if the name of the class, like in my case employee, is identical with the name of the table, and the capital letters are irrelevant here. So when I say identical, I mean these two are identical. So it's you don't have to take care of capital letter or not. So if it's a small or capital letter, it's not important. Okay. It's equals ignore case, to be precisely in a Java language. So in that case, that's unnecessary. So you might completely skip using this annotation, because in that case, automatically the framework will use the name of the class. Okay, but if the name of the table is not identical, like if the name of the table would have employees, for example, then you mandatory have to add the table annotation and make sure you specify the right name here. And this in the table annotation will be the name used in the queries created by the framework behind the scenes. This name here is just the name of the entity in the context. It will not be used on the queries. So the name used on the queries will be the one on the table annotation. Okay, so this is the difference usually. Now, it's unlikely that you will ever set a name on the entity in a typical scenario. So most importantly is to remember the name on the table annotation, because that's what usually you will need again when the name of the table is different than the name of the class, where in that case it's absolutely mandatory you use that. So I hope that answers the first question. Now if I continue, I need to add all the annotations, and I will detail now each and every annotation that I create. And I want to tell you that everything that we discuss is according to the Jakarta Jakarta persistence specification. In the previous lesson, I told you this is a very large PDF of about 700 pages. You can see it here. So it's a very large PDF describing everything in the specification. So that means that regardless of the implementation you use, if it's Hibernate or one else, if they claim that they fulfill the Jakarta EE persistent specification, then they will have to fulfill everything described in here. Now this is a document that I would recommend you go through and read and make sure you understand. This is the place where if you don't know something about an annotation, for example about Jakarta EE, then this is the place where you should go and ask for that information. It's not Stack Overflow, it's not I don't know, whatever other forum, or it's not ChatGPT. If you'd ask me, it's the PDF. So here, for example, if you got the entity class, you will see everything in the description of that entity. So what an entity means, with the examples, with everything you need to know, it's here. Okay, so that's what we will discuss. But let's take it step by step. So I will not very often go through the document together with you. It's just I wanted to show you the document and make you the recommendation of reading it. But in our discussion, of course, we will go on with examples, and I will tell you the most important things of all the annotations that we will use. Annotations that are part of the Jakarta persistent space. So normally all the annotations that you use, they should be a part of a package of one of the sub packages of this package. So again, for everyone, entity, you understood, is the annotation you use to make sure your JPA implementation understands this is an object that models a table in a database. Table annotation is not mandatory, but it's what you will use in specific situations, and most often is when the name of the table is not the same as the name of the class. So if it's not the same, then you have to use the table annotation for sure. Now there are several other reasons why you would use the table annotation. Sometimes you want to specify a different schema that you work with from a database. For example, you need to specify some specific constraints, or you want to specify some specific indexes, and sometimes using those, the JPA implementation might create some hints and put them on the query when they create the query on the database, but that's not guaranteed. It really depends on the implementation of that you use. So these are less often situations in which you would use the table annotation, but most often is because you want to specify the name of the table that this class models. Now the ID is mandatory. It's one of the most important things to remember, is that absolutely any entity has an ID. There is no such thing as an ID missing. So that's why if you comment this out, you will see that my IntelliJ is smart enough to tell me that something is wrong with my entity. So this ID can be, you will find it later when we discuss about inheritance in case of entities, and we'll discuss that. It can be inherited from a superclass, for example, or it can be declared it can be declared in the class itself, but it must exist. There is no such thing as an ID missing. This is a very interesting aspect, because in the real world you might have classes, you might have tables, in the database without a primary key. So usually relational databases technologies allow you to have tables that don't have a primary key at all. Even if you have a table without a primary key, the ID in the entity must exist. So even in that case, you need to find either one column or a combination of columns that is unique. If it's one column, we call this a simple primary key. And in my case, and in the let's say most cases, 90+% of the cases, you have an artificial primary key like the ID here that is set as auto incremented by a sequence or something. But if there is a case where the primary key is missing, then you have to create a composed primary key, which is again something that we will find out later how to do in one of the next lessons. But there is no such thing as missing. So you either have a simple primary key or you have a composed primary key. In the worst case scenario, you have all the columns of that table as a composed primary key. And that's the worst case scenario, because if that would not work, then it means you have duplicated data in the database, which doesn't make sense. It really doesn't make sense to have rows identical in the database. Okay, so that's something really wrong if you have that. So the worst case scenario, you don't find a combination of some columns, you have all the columns as a unique combination, and that's the worst case scenario, is that as a composed primary key having all the columns. But you need to have it. So there is no such thing as not having an ID, at least not with JPA. So yeah, that's the point. Now, same as the table annotation, you have the column annotation. So the column annotation allows you usually to specify details about the column. The table represents the table, the column represents the column. So for example, if the name of the field is different than the name of the column, so if I name this, say in the database employee ID or ID employee or something like that, and I don't want to use this name in the class. In my class, I simply want it to be ID and that's it. Then you must specify the name using the column annotation. Otherwise, by default, the JPA implementation will use the names from the code. So if you don't specify the column annotation, then it will use the name of the field. I will now put the table and the column annotation because I'm explaining them, but a good practice would be to avoid using these unless you really need them, so you don't have to put them everywhere. Okay, so normally is use only those annotations that you really need in your code. Don't use all the annotations. And I know it's debatable what I'm saying now, because some developers say, hey, I prefer using the column and the table all the time just because I want to make sure if someone changes the name of the class will still work. On the other hand, in my experience, that's not something that really often happens, and I do prefer to avoid the verbosity in code, because the more verbose the code is, normally the more difficult it is to understand it, and definitely maintainability of our applications is an important aspect, so we want to keep that in mind. So I can say then, what was next? String name and something. Let me check. So it's string name and string address. Name private string address. And you see this address here. Now I just put it as a string here, but if in some cases we want to have a separate maybe entity address, you want to have a separate entity, sometimes you want it to be or not an entity but just a part of the entity, and this is a very good example where I will teach you in one of the next examples how to use embeddable classes, which don't define entities but are somehow part of the entities represented as a separate table in the database. So going back, name and address for the moment is just a string, so I will keep it as is, and then I will define the getters and the setters, so that's it. So, and with that being said, now this is the simplest entity that you could create, no? And we just learned a couple more annotations, and you know that, for example, here you could add one of these in the database, and remember that you have usually one entity manager factory, but then normally you will create multiple entity managers, and each entity manager represents a context, and your application will not have only one context, but normally it will have one such context per use case. So usually you will create an entity manager every time you start a use case, and for it potentially you will have to start a transaction that needs to be committed at the end, and that is a must in case you have mutation operations such as adding something in the database or changing something, for example. But let me try something different now than I did in the previous lesson, because I of course want to teach you new things. So as you can see in my table here, I already have some data. So one of the first things that I want to teach you is how to grab the data using the primary key. And to do that, you of course, like for anything else in using JPA, you will use the entity manager, because the entity manager is the manager of the context. It manages the context in both directions, from the app to the context, and the other way around, and from the context to the database, and the other way around. So that means that if I want something from the database, it's still an operation on the entity manager that I will need to use, and that operation is called find. So to grab something by its primary key, by its ID, when you will hear me saying ID and primary key, in most cases I use them as synonymous. Okay, so I use them as the same thing. You need to provide the type, so you can say I want to grab an employee, and then that object is actually the primary key, so is the value of the primary key. So in my case, to grab this John Doe here, I need to provide the value of the primary key, and then employee E1, and that should be it. So let me go and say system out, and then just to make things relevant, just to make sure that you will see something, let me also override the toString method here. So I just chose the default IntelliJ toString implementation, where we will be able to see the ID, the name, and the address of the value. So this way we will see that indeed the query has been sent to the DBMS, data has been retrieved, and we were able to grab it as an instance of the object. This instance automatically will be part of the context once we have done that. So now if I'm running this, okay, this entity manager factory will be created based on a data source. So first of all, the data source is created. Oh no, this is not what I wanted to see. This is it. The data source. So the data source is created based on the details that we have provided. Then based on the data source, an entity manager factory is created, and then we can create as many contexts as we want. So the context is created at the beginning here. So this is a context created here, and again, we have an exception, but I will explain it why, because I forgot to do something. But let me finish this. So we create a context here, and then it's very important to remember to close the context. So that's why when you will see vanilla JPA used, you will also always see a try and finally, and you have a close on the finally. Usually when you use it with higher level abstractions such as Spring Data JPA, that's not needed anymore. Now why is this unable? Because probably I've copy pasted from the previous lesson example, and you see I've been using the name of the class that was in our previous example where we used this product. So I need to make sure org example entities, and today is something else, it's employee. So let me add the correct class name here, otherwise of course it will not be found as an entity. And again, remember that normally an application should detect these entities using reflections, so you don't need to manually specify them somewhere. Of course, you have this opportunity, you can do that if you want, but normally that's not the case. So I changed that, and I gave it another try, and here it is. See, so the employee has been retrieved. Now imagine what happened. If this is the database here, I don't have an icon now anymore. I usually use that cylinder, but I wasn't brave enough to take it before our live event, so I will simply represent it as is. So what happened is when we tried to find by ID, the thing is a query has been made automatically, and then the data has been retrieved. Okay, so this is our find. This is where the query has been made, and then inside our context here we have an instance. So if you call find multiple times, if you call find multiple times on the same primary key, there will not be multiple queries sent to the database. It will be only one, because the first time we do that, the instance becomes part of the context, and once it's part of the context, the next time you will query for it, you will already get the information. So you don't need to do that. So that's basically it. So yeah, that's basically how it works to simply get one of the employees. Now I will do something else. I will say E1 set name Laurencio. Okay, I just put my name here because now you have John Doe. Okay, and I'm gonna run it. Since the only thing I did is to set the name on this entity, and I'm gonna run it. So let me do that. Okay, wait a bit for it. So the name here appears as my name, and if you go to the database, you will see something interesting, is that in the database it has been as well changed. And I think this is one of the most encountered misunderstandings for someone who starts working with JPA. And that's also because you see, when you work with that, I see something very interesting when people now start working and they don't know the behind the scenes, and they start working with Spring Boot and Spring Data. And in Spring Data there is a method called save, and sometimes I see developers calling that save at the end, but the only thing they do is changing a value on an entity, and that's not needed. Calling the save there is not needed, because that save it's necessary when you persist something. It's a combination of operations that we will learn. It's a merge and a persist there. But when you change values, you don't have, there is no update operation in the entity manager. So there are multiple operations we will learn, such as the find, but update is not one of them. There is no such thing as update method for Hibernate or any other JPA implementation. Why is that? Because the philosophy of the JPA implementations work differently. Remember what I told you, and the way I told you to understand this, to imagine this. So this is, if this is the entity, yeah, the entity has an ID. Let's make this a bit smaller. Not that small. So it has an ID. It has a name. And it has a description. Not an address, sorry. Okay, so this is my entity here. What my app does, so it retrieved through find this entity from the database and added it to the context. Okay, and then I have changed the name into my name here. Remember that the way it works in JPA is that at the end of the transaction by default, which in my case is here, the context is mirrored to the database again. So automatically, by simply changing this attribute, when the app reaches the end of the transaction, Hibernate will see all the changes that happened in the context and will map them in the database. That's why a simple change on an attribute of an instance transforms automatically into an update on the database, which doesn't happen here. So pay attention, it's not on line 26. When line 26 is executed, there is no update on the database. This is simply a change of an attribute in the context. But when it reaches the end of the transaction, it will create this update. Now let me ask you something else. What do you think it happens if I set the name back to John Doe and then I set it back to mine? So now in the database, it's my name. Okay? So this is not relevant anymore. Okay, this is my name, and I set it to John Doe, and then I set it again to my name. Will there be any query that will be sent to a database if I'm running this application? The answer is no. So now there is no query sent to a database. It's basically, it is one, it's the find. Fine enough. The find will happen at this line 25, because when you call find, what happens first is that the entity manager tries to see if the data is already in the context. And of course, the context has just been created here, so there is no data. Initially, the context is empty. The context gets created together with the entity manager. So you start the transaction, you run, this query is sent to a database, grabs the data, stores it as an entity in the context, changes the name in the context to John Doe. There is no query happening here. Changes it back to my name, it becomes again identical to what's in the database. And it reaches the end of the transaction. Because nothing changed, these two operations here are irrelevant. Because in the end, the context already mirrors the database. And because it already mirrors the database, there will be no update sent to the database. So the funny thing about using JPA is that you always have to understand you are working with a context that will be mirrored at the end. So you don't know exactly which will be the queries that will be created, that will be sent. So you only know at the end which are the queries. And you can print those queries to see them. And we will see that as well in one of the next lessons when we learn investigating this kind of stuff. But the idea is that you can't simply use the same JDBC philosophy where you know when you execute update, execute query, and you know exactly when you call the execute update, you execute a query in the database. That doesn't work anymore here. Here you can simply have something like remove, then persist again, and nothing happens. Now you can see something like, and let me show you now another operation from the entity manager. is remove. Okay, you can say remove that, and then you can say and if I'm careful enough to set here the exact details I have in the database, then there will be no query sent. No, so if I'm careful to put exactly what I have here, and then I say persist. So this could be another example of an application that only sends a select, because all these operations here, okay, will only reflect in getting the data from the database, removing this instance. But where is this removed from? Is it from the database? No, this is a remove instance from the context. There is no operation with the database. Okay? Even the find itself for the app is from the context. Now, the fact that in the case the context is empty or doesn't already have that object, the JPA implementation will know to query the database. That's another thing. That's indeed what happens, but that's another thing. You are still working with the context. Because if you run the same find again, there will be no more select from the database. That find will simply get you from the context. You remove it here, you remove it from the context. So if I remove this from the context, and then I put it back in the context, then this will be again identical at the end of the transaction with what I already had. So see, it's a bit different the way we think about working with the database when we use JPA. Is not the same thing as the JDBC, vanilla JDBC, which was kind of feels more clear, because you know, you feel more in control there. You feel more in control about when things happen, because you know exactly, I call the execute method, I know exactly on that line a query will be sent to the DBMS. In case of the of a JPA implementation, that's no longer the same thing, you know. So what are the operations that we usually need to know? So I must enumerate them a bit to make sure that I put in place also so you know what we will learn. So persistent find, you have already seen, and then you have remove, and then you have merge, and then you have refresh of the context. Okay, and I think this is it. Let me check to be sure. Oh, detach. Okay. And basically, next lesson, because I don't want to rush on that, there are many. Next lesson we will learn about the life cycle of the entity, and you will basically learn what you can do with the entity on the context using these operations here. So see, no update. Okay, so this is basically all the operations you can do with the entity. So persist, which is adding an entity in the context, and of course it's not only adding it, it's also marking it to be persisted. It's a little bit more than this, but you can just think if you think about adding it to the context, I think that that's enough for the beginning, because you don't have to fill your mind with all the details from the beginning, and it will be enough. Find, you saw already what it does. It finds by primary key. So finds by primary key, that means get from DB and add it to the context if it doesn't exist already. Okay, and then remove, it's removing it from the context. It's actually, it's not removing, it's marking it for removal, this one. Actually, I might have been wrong when I said in the example previously, but anyway, the point was another one, so it's not completely bad what I said. So marking entity for removal, and then detach is actually taking the entity out of the context. Refresh, mirror the context from the database, and merge. Merges an entity from outside the context to the context. Now, merge might look similar to persist, but the difference is that for merge, the entity should already exist in the database, so you cannot merge something that doesn't exist. So if you want to add something to mark it to be persisted, you need to add a persist. If you have an instance outside of the context which hasn't been, you have simply created it, no? Like for example, what happens here if instead of using this, I create an employee E1 new employee. So E1 set ID 1, set name John Doe, set address something, and then I've proven at the in the previous example that if I run something like this, no, because John Doe and something, they don't correspond with what's in the database at the primary key 1. No, you must agree with me that the details are different, no? And in the previous example with find, when I run it, it changed the values, and I explained it that at the end of the transaction, the context is mirrored, no? But if I'm running this, so just to make sure, I will refresh here. So see, it's still my name, and if I'm running the application now, it will still be my name there. There will be no update, no? And then you might get confused, and you might wonder, hey, what's the difference between what happened in the previous example, where you just showed that you simply change the value and it works and it changes in the database, and now why this didn't change to John? The reason it didn't change is because creating an instance like this, it creates it outside of the context. So while it's true this now has the primary key 1 and different values, remember that at the end of the transaction, which is this line here of mine, the context is the one mirrored to the database. So when instead of this I had the find, it worked for me simply to say E1 set name and change it in the database. So if I'm running this now, it will work. Once the application executes, you will see that everything is now updated, because find, is not only a query that gets an instance, it does one more thing. It also makes sure that instance is in the context. So that's why setting the name had an impact on the database at the end. This line mirrored the context and made sure that the update happened in the database. And now it's Mary here. But when instead of doing this, I'm doing this, it doesn't. Because this employee created simply with the constructor is not part of the context. If I want to make it part of the context, I can merge it. And here's the merge operation. So the merge operation is different from persist because it's a case where you know the entity exists in the database but not in the context. And instead of querying it, you create it and you merge it to the context. If I do this, now at the end of the transaction, I should see in the database that the name changes from Mary, or whatever the name is now, to John Doe. So if I'm running it now, it should have an impact. Why? Because merge put this entity in the context. So the difference between the two examples is that with one of them, when we used find, see, it changed to John Doe. So what find does, find gets it from the database and adds this to the context. So then when I change the name, the change has been reflected at the end of the transaction. While in this example, in this last example, what we did is we externally just created this instance. And then based on the primary key value, we merge it to the context to make sure that the other changes will have an impact and will be stored in the database. Okay, so a question probably you said already, but which would be the definition of the context? So the context is, you can imagine it as a collection which the JPA implementation, Hibernate in our case, works with. Is the place where we put the objects that Hibernate will work with in a specific for a specific use case. That's why, and that's basically what I try to prove today, is that if something is not in the context, then Hibernate doesn't see it. So that's why without this merge here, there was no impact on the database. No, so now you see the name is John Doe, is the last we set. But if I try to make this something else, like Alice, and I don't have the merge, this is, even if it is an instance of a class marked with entity, if the instance is not in the context, is not one of the objects Hibernate will know to work with, and changing the name from John Doe to Alice will have no impact, will not be mirrored to the database. So the lesson is, whatever we make, if you want it to have an impact on the persistent layer, which is the database, you need to make sure one way or another that is in the context. So in my case, so I ran it, there will be no change. Alice will not be in the database. It's still John Doe there, because there is no, I made no operation. I executed nothing to make sure that E1 is part of the context. So today we learned actually two ways. We learned three ways actually. One is from the last time. in which you can add something to the context. And you actually, yeah, 3 ways. And next time we will deal with the other operations here, no? So the first you learned is persist. Persist is used to add to the context an entity that represents a new record. The new entity will be added to the context and it will be marked to be persisted. The result at the end of the transaction will be an insert in the database. You also learned find. It uses the value of the primary key to get an instance from the database. So, and I just saw I forgot one of the operations, get reference. Okay, this is another one that we will learn in the next lesson. So the second one is find. Find gets the value from the database and puts it in the context. So the result is that if the instance has been found, it's also at the end part of the context. And the third way you learned is merge, which is having an instance created by us and then put it in the context, force it into the context so that we can then operate with it. And then of course we have to discuss about ways you can get something out of the context. So you can detach something. For example, I could say merge this, and then I can take it out of the context, detach, which detach is the opposite, if you want, from merge. If you want to take it out of the context, so it has no impact. Or you can mark it for removal, which it means it stays in the context, but it will be removed. Or you can refresh it, which means you made changes on the instance, but you want to take the data from the database and refresh the context with it. Again, I'm not going to do that now because we end our time, but in the next lessons I will give you examples with all the remainings. So the purpose is, in the end, you first of all understand very well what those operations do with the context, and then once we clear that on a simple case, we will discuss about relationships and ways to model a little bit more complex scenarios in the database. The last question, and then I will end. What would be the result if we use persist instead of merge in that example? So I have to check in the specification to make sure, but I think there will be no change since the idea. I think that there will be the same thing since the primary key already is in the database. It will simply put it in the context, and then it will result in the change. But I will check that in this large document, because again, I don't know by heart all the very edge cases of this. I learned them some point, to be honest, when I gave my certification on this, but that was a long time ago. Because usually in real world apps, well, you don't do corner cases like this. Now you usually do things with a purpose, and the purpose is not persisting something that you know it already exists in the database. Cool. So with that being said, guys, thank you very much for being here with me. I hope you enjoyed this second lesson, and I'm looking forward to seeing you in the next lesson, where we will discuss the remaining parts of the operations. We will make some more examples, and then we will proceed with complex modeling of the entities in the database. With that being said, cheers everyone, and see you next time.